Yes, we are here to have a discussion about IoT kit, the experiments which we are performing under the IoT subject that we are going to demonstrate over here. So for that we have multiple cables. So this is a power cable which we are going to use as an adapter, which is 12 volt 2 ampere. So that will be connecting as a power supply to the main board. This cable is having an adapter point, and this adapter point we are going to connect to the board is also having a power on switch over here. So this is the off condition. If we press it on right hand side, then it will be on condition. So right now it is in off condition. Again, as we are going to use a IoT kit, we have a Raspberry Pi board over here. This is a Raspberry Pi chip, and this is a crystal oscillator for Raspberry Pi. So this board is Raspberry Pi, and this entire platform is having all the peripherals on one side. So these are the peripherals. This is Raspberry Pi, and this is Arduino board. So like this, all our connections are available on one single board, and whenever we want to interface any peripheral, so for that purpose we have the section. This is the first section, the upper section, which is used for interfacing any peripheral with the Raspberry Pi part, and the lower section, this is the section where Arduino interfacing can be done. So the second part, this entire second row belongs to Arduino, and the upper row belongs to Raspberry Pi. So for example, if you want to interface ultrasonic sensor, this is ultrasonic sensor having transmitter and receiver. So this ultrasonic sensor is having a cable having 4 ports into it. So these ports we are going to use, and we are going to interface to the ultrasonic part. So here ultrasonic name has been mentioned. Here you can observe it. Yes, so this is ultrasonic name which has been shown here. So we'll place this cable like this. So this is our ultrasonic sensor interfacing. So why we are connected over here and not at this side? Because we want to interface ultrasonic sensor with Raspberry Pi. So that's why we have made a interfacing here. And for that we have this parallel cable. This parallel cable is transferring program from Raspberry Pi to the peripheral. So this is just a interfacing cable which will connect this board to the lower board. So that is what the interfacing. So the below board is the development board, and this is the Raspberry Pi controller board. So this we are interfaced with peripherals. So to have a power supply for this, we have one cable. This type of cable is there, which it is a 2-pin cable which will transfer power from development board to the controller board. Just a second, I will interface it. So why we need this cable? The power code which is available here, it is providing a 12 volt supply to entire board, and each of the peripheral requires different power supply, 7 volt, 5 volt, etc. And Raspberry Pi requires 3.3 volt. So to get that voltage, we are transferring a power supply from the lower development board. This is our development board, to the upper board, that is a Raspberry Pi board. So this is the power cable applied to Raspberry Pi, and this is the power cable applied to the development board. Okay, so similarly our Raspberry Pi is operated as a CPU. It has operating system into it. So to have a usage of this processor, we need to have interfacing of screen also. So what we will do, we will replace our regular CPU. We will replace our regular CPU, and instead of this CPU we will be using Raspberry Pi. So as we are replacing that CPU, means all the interfacing of this CPU has to be connected to Raspberry Pi. So what we will do, we have this video cable, VGA cable, which is also called as parallel cable, right? So this parallel cable is connected to a screen on one side. Okay, this is a screen, and on the other side this cable is connected to a CPU. So what we can do, this we are going to connect to a HDMI cable. This is a HDMI cable. This is the HDMI cable. So in this HDMI cable, this is the port. Okay, HDMI port, parallel cable port, and we are going to interface this parallel cable with this parallel port. Okay. So like this will interface, and we will screw it so that it will remain fixed. and this is the HDMI cable. Another type of port is HDMI port. So it is a connector, HDMI to VGA connector. It is called as HDMI to VGA. So we have VGA connection at one side and we have HDMI connection at one side. So we are going to connect a monitor. We are going to connect screen to a CPU. So this is CPU. For CPU we have connected a screen through a VGA parallel cable. Okay, and this is the HDMI port which we have used here. Now similarly, as this is CPU and this is used for screening purpose, we have a keyboard and mouse interface also. So these are the two USB cable. One is for mouse and another is for keyboard. So we are connecting over here. So we have 4 USB ports. So out of that we have used 2 USB ports, one for keyboard and one for mouse. And other 2 USB ports are also there where you can connect other pen drives or any hard disk, any type of USB device. Similarly, we have a LAN cable connection. Here we can connect an internet. So Ethernet cable, LAN cable can be connected over here. So that is what the Raspberry Pi board we have here. And now we'll be looking after the other parts of the board. So as we have said, the first part we had a Raspberry Pi. Then we have interfacing of Raspberry Pi. Then we have interfacing of Arduino. Then we have Arduino board. Okay, so for Arduino board we have one more kit on which we will be performing Arduino experiments. That's why we'll leave this part right now. Okay, so this is one part of Arduino. So for to performing experiment on Arduino, what we will do, we will have a separate kit for performance of Arduino experiment. So this is the Arduino part, this is the Raspberry Pi part. Now we'll look after the peripherals what we have on the board. So first part is this LED. This LED are sandwiched with switches. This is a two-way switch. So by default all are in off condition. We can turn it on. Okay. So whenever power supply is applied and we will be programming it, we will be observing a different pattern of LED which will be glowing. So along with LED and switches, we have a pull-up register bank over here. This is the same register bank which we have observed in AP also, in ARM processor kit also such banks was there. In addition to that, we have a IR sensor. This is the IR sensor, the black and white color. This is the IR sensor. You know what is IR sensor, infrared sensor, where we can transmit a data through an infrared range, and that will be a wireless communication. So for that we have IR sensor. Above that we have one more sensor called as PIR sensor. That is proximity IR sensor. So it is used in playstations where jockeys are used. So you can rotate any surface, you can have a rotating surface on this and it will measure the amount of rotation which you have done. So in playstations you are using this as a jockey where the degree of rotation is measured. So that type of work will be done on this part. Okay, after that, adjacent to this we have ultrasonic sensor. So ultrasonic sensor is having transmitter receiver which is going to measure the distance between the obstacle and the sensor, and it will let us know how much far or how much near that object is. So right now we have made a connection for ultrasonic sensor only. So that's why we have connected an interfacing cable from this port to a Raspberry Pi ports, because we are interfacing ultrasonic to a Raspberry Pi. Along with that, what are the different peripherals? So we have a breadboard also with us. So you can connect any peripheral with the breadboards, any component, any IC which you want to interface with Raspberry Pi or Arduino, you can connect on breadboard also. And again, next part we have about DC and stepper motor. So DC, stepper and servo. Why it is? Because this first port is for DC. Name also suggests first is DC, second is for stepper, and third one is for servo motors. So we can connect 3 motors over here, and for that we have an additional power cable also. So that power cable will be interfacing with the main power supply, and we will getting a power for it. Next, at the upper part we have a relay, buzzer and a solenoid. So these are the 3 peripherals which will be used in one of the experiment where relay, buzzer and solenoid, all 3 will be operated together. So one common program will be discussing how relay and buzzer and solenoid is operated. So solenoid is an example which you must have observed in your vehicles, where you can lock your doors by just one single key push. If you push the key, all the 4 doors will get locked. So for that we use solenoid. So we will be having an experiment for that as well. After that we have one module here named as Wi-Fi module, that is ESP8266. So by using mobile hotspot, by using mobile internet, we will make an internet connection with the IoT kit using this Wi-Fi module. Along with that, we have RFID module. This is card reader. So whenever RFID card is taken in the vicinity of the reader, it will read the RFID number and it will detect whether that card is valid card or not. After that, we have two more detectors here, two more sensors, like one is sensor, one is actuator. One is LDR, light dependent register. Here the presence of light and absence of light can be detected. So device is not available as of now. Whenever we need it, we just need to plug in inside. So that is all LDR, and similarly the case is for RGB. Just above that, just to the top side of the board, we have a DHT 2211. That this is a digital humidity temperature sensor. It will measure the temperature and humidity of a board which is available in the surrounding, and respective temperature and humidity will be displayed. So if we interface this sensor with LCD, then we can measure this temperature value, we can observe the temperature value on LCD. So likewise, these are all the peripherals we have. So that's it from this video. In coming videos, we'll be observing about multiple experiments. Okay, thank you.